Hi Bobcats! In this video we're going to look at our third and final set of compounds for nomenclature for this chapter, which are the alkanes. And once again, our objective will be to write names and formulas for alkanes. Alkanes are compounds that look like this one that's drawn down here. The backbone of the alkanes tend to be a chain of carbon atoms. So we've got, in this case, 5 carbon atoms in a row. And as we're going to learn a few lectures down the road, carbon likes to form 4 bonds. So any bonds that are not already a bond to another carbon atom get filled out with bonds to hydrogens. And so we end up adding 12 hydrogens in here to complete all of the bonds. So alkanes are these compounds that contain only carbon and hydrogen. Now, carbon is a nonmetal, and hydrogen is also a nonmetal. And we said earlier that if you have a compound that's a nonmetal plus a nonmetal, it would be a covalent or a molecular compound. So it turns out then that alkanes must be a subset of molecular compounds. So let's look at this Venn diagram. If we were to draw all molecular compounds as the purple circle, alkanes would be that blue area. This is really not to scale. The alkanes area should probably be much, much smaller because there are so many different molecular compounds out there. And then last but not least, the formula for an alkane is given by CnH2n plus 2. Now, when we write the formula in this manner, the N value is the number of carbons. So N is equal to the number of carbons. And so once we know how many carbons there are, we can generate the number of hydrogens by doubling it and then adding another 2. And I'd like to show you where that formula comes from. If you look at each one of the carbon atoms here, you'll notice that it has a hydrogen above it and another hydrogen below it. So that's where the 2N comes from. Each and every carbon has 2 hydrogens attached directly to it. In addition, there are 2 extra hydrogens that cap off the N's. So that's where the plus 2 comes from. So once you know the number of carbons, to figure out the number of hydrogens, you simply double the number of carbons and add 2 more to cap off the N's. This slide shows the rules for naming alkanes and writing their formulas. We are going to specify in the name of the alkane how many carbon atoms it has with a numerical prefix. Now, these prefixes are similar to the covalent prefixes. In fact, if you look at 5 through 10, they look very familiar. 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. We're dropping the A at the end of them because we're going to put an ane suffix or ending on it, so we don't double up the A's. We don't say octaane, we just say octane. But the first 4 are kind of strange. 1 carbon is meth, 2 F, 3 prop, and 4 bute. And then also just remember that our formula is CnH2n plus 2. On the next slide, we'll take a look at some examples. Here are some examples. In the first one, we are given the formula C4H10. The fact that we have 4 carbons sets the name for this alkane. The prefix for 4 is bute. So we'll write butane. Butane would be the name for C4H10. Notice if we start with 4 and we double it, we get 8, and then we add another 2, we get 10. So that's where the 10 hydrogens come from. In the next example, we have propane. That prefix prop tells us that we have 3 carbons, so C3. And then to figure out the number of hydrogens, we're going to double that 3. So 3 times 2 is 6, and add another 2. So 6 plus 2 is 8. C3H8 is the formula for propane. Let's see, propane is what you'll find in gas bottles, like for a barbecue grill. Butane is what cigarette lighters are made out of, or that's the fuel inside of a lighter. Let's see, this next one, CH4, having a single carbon atom tells us that the prefix is meth. And so this becomes methane. And now last but not least, down here we're given a structure for an alkane. So let's see if we can write both its formula and its name. There are 2 carbons, so the formula will start C2. And if you count up the hydrogens, I believe you will find there are 6, so it's C2H6. Because it has 2 carbons, the numerical prefix is F, and we will end it with ane, ethane. One way that alkane nomenclature can get asked on a test is something like this. How many hydrogen atoms are in pentane? So think about what the formula for pentane would be. That prefix pent tells us that there are 5 carbons. To find the number of hydrogens, we're going to double that. So 2 times 5 is 10, and add 2. So that becomes 12. So C5H12, there are 12 carbon atoms. Our objectives were to write names and formulas for alkanes.